Okay, June 2019, paper 1. So we've got a molecule P. It's being ionized by electrospray ionization this time, and I've got a graph. Okay. Describe the process of electrospray ionization. So this is how you prepare the ionized sample. Remember, the time of flight mass spectrometry is the same apart from how you might prepare the sample. So you put an ionized gaseous sample into the time of flight apparatus, then the ionized gaseous molecules will be attracted towards an electric field or some negatively charged plates with holes in them. They then travel down the tube. The lightest particles hit the detector first because they go the fastest. They hit the detector plate. The ions turn back into atoms or molecules. They gain electrons from the plate to do so, and the electrons being gained from the plate create a current. The larger the current, the more abundant, the commoner, the more particles that are hitting that plate. That's always the same, but the preparation of the sample can be different. It can be by bombarding the sample with high energy electrons. That's called electron impact. And P, gaseous, would turn to P plus gaseous and an electron. But in this case, they're preparing it with electrospray ionization. It's always worth 3 or 4 marks. The first mark is that you dissolve, the liquid sample is dissolved. Now, if you really want to know, it's dissolved in a solvent, something that will dissolve it, such as water or methanol, something that's volatile. Water or methanol boils at a relatively low temperature. It's got a low boiling point. That means it's volatile, and polar means that the water or the methanol has got delta plus, so delta minuses. But dissolved in the liquid sample will get you the first mark. Then it's injected through a capillary needle, okay, a very, very fine needle. What that does is it turns it to a gas, because when it comes out under high pressure from the very, very fine end of the needle, it turns into a fine mist or a gas. So it's basically turning it from a liquid now into a gas. And then a very high voltage is applied to the tip of the needle, and each molecule gains an H+. What it actually does is the high voltage combined with the water and methanol, which is able to provide the H+, then bonds the molecule to an H+. So if we look at the equation, P, gaseous, got to be gaseous, and after all it's been converted into a mist through a fine capillary tube under high pressure. That's converted it into a gas, P, gas, and a H+, so that's come from the water or the methanol with a high voltage to bond them together, makes pH plus gas. That's electrospray. So the sample gains an H+, still starts and ends up still as a gas. But if you notice, it's gone from P to pH+, so it's gained an H. So what was the relative atomic mass of P at the start? Well, we know at the end it's 556 is the mass divided by the charge. The charge is +1, so the mass of the particle is 556. Once it's gained an H, which has got an H+, once it's gained that H+, now an H+ has got a mass of 1, so the P beforehand must have been 1 unit lighter. It must have been 555 before the P was turned into pH plus gas. Now the next one's fairly straightforward. You've got a lot of data to put into an equation, but it's fairly straightforward. You've got to remember that velocity is distance divided by time. Think of your car again. Velocity or speed in miles per hour, or kilometres per second, you could say. Miles per hour, kilometres per second, per means divide by. It's a measure of distance divided by time. Velocity is distance divided by time. It's giving you the distance of the tube, 1.5 metres, needs to stay in metres. 1.5 divided by the time will give you the velocity of the particles. Then you plug it into kinetic energy. You've been given kinetic energy equals half mv squared, so let's use it. You've been given the kinetic energy, you've got v, so you can work out v squared, and therefore you can work out what m is. Now m is the mass of one particle in kilograms. So it's 2.81 times 10 to the power of minus 25 kilograms. To convert a large unit like kilograms down into a small unit, you multiply by 1,000, so that becomes 2.81 times 10 to the minus 22 grams. Okay, that's for one particle. So to work it out for a mole, which has got Avogadro's number of particles in it, you multiply by Avogadro's number to work out the mass in grams for one whole mole. And it will come out as 169 to 3 significant figures.